Awesome. Thank you. So to kick us off, panelists, so that our attendees can get to know you a little bit better, could each of you say who you are and briefly describe your work? And let's go in order of alphabetical by last name, which is going to challenge me here. Justin, why don't you go first? Justin, you're muted.
Sorry about that. Hello and good afternoon, everyone. I'm Justin Ballinger. I'm the Deputy Director for the Data Science Initiative for the Atlanta University Center Consortium, which is comprised of 4 HBCUs, or historically Black colleges: Morehouse School of Medicine, Clark Atlanta University, and Spelman College. And we work across our 4 institutions in terms of building data science programs, and also working with students and with faculty to build research in data science, particularly as it relates to social justice and data science. We offer a few programs, such as a pre-freshman experience in data science for incoming freshmen to the AUC. And then we just launched a $10 million grant from the National Science Foundation to begin a National Data Science Alliance, which will encompass all 103, depending on how you count them, HBCUs in the United States, which will be working to build out data science curricula and research among faculty at those institutions. So I'm very excited to be here and to join this panel. Thank you.
Yeah, I heard about that NSF grant. Congratulations to your organization and to you, Justin. Jima, why don't you take us off next?
Great. I just want to echo what Justin said. I'm super excited to be here with the panelists and everyone today. I'm Jima Mojika. I'm a senior research scholar at the Friday Institute, and I'm super lucky to work on this great team with Holly Lynn Lee and Emily Thrasher. I just have to say all of my work is done in a great group of people, and those two really are driving all the work we do. So the things I talk about today will be very much related to their work as well. But we have lots of projects on our team where we call ourselves the Hub for Innovation in Research and Statistics Education. We have multiple projects. They all are striving to build foundations for K-12 data science initiatives. And we luckily have gotten 2 recent big grants to support different efforts. And most of the work that I work in is building learning spaces for teachers to continue their professional development in statistics and data science, and also to build curriculum materials and technology tools to also support pre-service teachers.
Fantastic. Thank you. Carl?
I'm going to avoid the "you're muted" thing. Thank you very much. It's a pleasure to be here. I'm Carl Schubert. I am a professor of practice at the University of Arkansas and associate director of the data science program, and I led the team that created the Bachelor of Science in Data Science here. I might add that I worked very closely with, we got some assistance from the North Carolina State University Institute of Data Analytics. And in fact, one of their faculty members is on our advisory council. I also co-lead a team as part of an NSF EPSCoR grant to create a data science ecosystem for the state of Arkansas that includes the HBCUs and other 2-year schools in creating 2+2 programs. And then we have taken that and made it wider. And I was asked to lead a team to develop a data science track in our Arkansas computer science education program for the state. And I did that, so that becomes effective this coming year. And so there will be a pathway for students. We basically developed it, a 3-year track as key elements of our first-year program here.
Well, thank you. And last but not least, Eric.
Hi, everyone. Eric Van Duzen from UC Berkeley. Been working in this space for about 5 years. I find it a really exciting and stimulating space because there's a lot of new stuff to get built and there's like new collaborations to be made. So personal passion of mine is doing interdisciplinary work and seeing that we can get data science out of just CS and stats. Working with social science faculties. I myself teach a class that's intersection of data science and economics. So if anybody's interested in that, that's where I'm out there innovating. Have worked for a few years on programs to build data science modules in other types of classes all across campus, and data science connector classes that are like a 2-unit seminar that illustrates the use of data science in a different domain. So I have a part-time lecturer appointment and part-time staff appointment. As a staff person, I work on outreach. So a lot of people come to UC Berkeley as sort of like an early mover in the field. And I do a lot of like explaining our curriculum. I lead a workshop every summer for data science educators. If you're interested in that, happy to share that out. And it's a great way to build community and find other people entering the space. And I also help a lot of California community colleges who are interested in bringing data science into their curricular offerings. I'm also work with the technology platform, so I'm pretty passionate about like open science, open source software, and that's a big part of the advent of data science, I feel like. And it requires people to sort of translate between people who are familiar how things have been done in the past and people who are familiar with these sort of new tools and new approaches. There's some really interesting things about taking things from the open software world and sort of applying them to curriculum. And this has sort of led to like a real flourishing at the higher ed level. How can we make curriculum that's more like tradable and exchangeable and mix mash upable? And how can we use these new teaching tools in a way that creates synergies across universities?
Awesome, thank you. So what you're saying is you don't sleep, basically. There's a lot there. Great, so you all have lots of different hats you wear, but we're going to focus in specifically right now on the K through 12 environment. So could each of you tell us what some of those key data science learning goals should be for K through 12 educators? How should they prepare their students for success in higher education? And does anybody want to go first, or I will call on someone?
I'm happy to jump in. One of the things that I think is very important for preparing us to deal with data in our everyday lives is just having these experiences where we're solving real problems that are relevant, hopefully, to our lives, but real problems in a real context where we can use data and we can make evidence-based decisions, based on exploring these bigger, messy data sets. But again, the whole goal has to be, we've got to have a real problem. It's not something made up, right? A story problem or wraparound problem, so that teachers can engage students in these critical type thinkings so that they can work through these problems. I think another important piece of this is developing certain dispositions. We want to get students curious. We want students to be resilient, right? When we're working with big data to solve big problems, they're going to have obstacles. So we want to encourage students to have those opportunities to learn to pivot and to overcome challenges with data, to work in teams, to rely on experts. And a lot of this requires, Eric is talking about technology tools, knowing what the right tool is, right? There's not one tool that's going to work for all across K-12, but there's different tools for different parts of working with data to solve problems. So I would say, building those skills are super important. And I'll go ahead and stop there.
You're actually jumping ahead in my question queue. I have a question very related to the messiness of data, but I want to stick on this question for now. Eric, Carl, or Justin, do you want to comment on what are some specific learning goals that K through 12 educators should focus on to prepare their students in higher education? Carl, I saw you have a hand.
Yes, I agree with what Gemma said, and a few things that I would add to that. To help do that, we've instituted in ours using case studies, because part of the case study is not only understanding the data, but developing a story around it to be able to communicate the results. And so a whole lot of it includes teaching them how to visualize things, teaching them how to do presentations, how to communicate to less technical people. That's a key element. And then working with non-preformed data sets. So a lot of the ones out on the contest sites are designed to show a specific thing. So we have them going to just government data sites and other data sites on the internet that are just exact data, data that are dirty, incomplete, no data dictionaries sometimes, things like that. So they get used to the real world. And then the other thing I think that's important is the open-ended problems. I know, even in the first year students, I know the things that they hate because they tell me this. They hate open-ended problems. They hate working on teams, and they hate having to do everything but maybe the programming. And I tell them, okay, well, but trust me, after having managed thousands of people in this area and 35 years in industry, I can tell you these are the things you have to learn how to do. And so, they whine about it, but they have to do it anyways. And then when they come back from their first internship, they say, well, God, it's amazing. They put me on a team. They gave me this open-ended problem and the data was dirty. And I had to go talk to the people to find out if what they really wanted done is what they really wanted done. So it's integrating those things in a smaller scale, including modeling, with Excel or a spreadsheet thing. In high schools, K through 12 is doable. All those things are doable. It's just maybe less technical and less of it and more spaced out. But starting with a model that includes maybe these 6 outcomes is pretty important. And you can start easy and then work your way up and just make it more complex. So like in our first year university course, I teach that in 2 semesters, these things with real problems. And then it's basically mini practicum for the final project for each semester. And then when they have me in the practicum, it's like, well, I don't have to teach you how to do this, there's this. So now you can focus on the problem at hand with the industry partner.
Great, thank you. Eric or Justin?
Yes, and I think I'll just piggyback a little bit. Really leaning into the communication piece and having students like across the AUC, we set up a framework for the data science minor courses that all of the institutions follow, and a great piece of that is communication and being able to visualize data and understanding what aesthetics need to look like for individuals to be able to understand data. Because I think many of the students that we get into that enter into our programs, they're adept at maybe having memorized some equations and a few ways of visualizing data. And so like if I can memorize this equation and I can throw up a graph, then that should mean that it's understandable, and that's not so true in many of the fields that we work in data science. So really understanding those elements of communication and design. And there's some really great open source software platforms such as Google Data Studio that will allow teachers and students to work with Excel spreadsheets to produce amazing visualizations and to be able to truly communicate and tell a story with the data that's able to allow individuals who may not be experts in data or maybe lay people to understand what's happening with that data.
Yeah, 100%. I love this emphasis on teamwork and communication. That's so vital. Eric, do you have anything you want to add to that?
Yeah, I do. I would say, my principles for like what is data science education would be the same at the university level as like at a high school level. It's something about you got to learn a little bit of coding, or something about, interacting with the computer, some computational thinking. How does the computer think about things? You got to learn some inferential thinking, something about how to structure a question, how to test a hypothesis. And then I think the really important thing is like leading with data, illustrating things with data. Formulas come after, but like get the students' hands on the data to illustrate a concept first. And then let's go to like, the math behind something after that. But leading with data, I think, is something that we're all doing here. But I also want to add, I think there's some controversy here. I think if you just go to data science for everyone stuff and you follow Zark, you'd be like, oh, everybody's ready to go. This is awesome. I think it's a little more difficult and messy, okay? I want to say that some people are ready to reformulate 10th grade math and have a new pathway that's not Algebra 2, that's data science. And some people are not ready for that change. And they're like, we got to stick with this calculus pathway that's going to lead people, to higher ed. And I would say, if you want to come to UC Berkeley and be a data science major, you should probably take AP Calculus in high school, right? So there's some part of it that's I want to say this is, has STEM in it, and it has a pathway towards the upper division math that you're going to face eventually. So I think there's just a bunch of controversy about where this is going to play out at the high school level. I think it's exciting and engaging, and people are like talking about what belongs in math classes. And it's great, but I just want to say, like, a bunch of unresolved stuff in this place.
You are
There-
so jumping ahead in the questions.
There is a lot of danger in that. And in fact, this came up because in the computer science side in high school, which isn't really university computer science, they are telling the students that algebra is enough. And so, I've been working with our head of STEM and computer science education in the state to differentiate between programmers and computer scientists. And there's a huge difference, right? One can program, write programs for you. The other, computer science, has got to do a higher level of things. And a data scientist also, in fact, the companies told us they wanted a rigorous data science program. So besides Cal 1, Cal 2, and multivariable math, which is linear algebra, and Cal 3, they go through a year of probability and statistics, statistical learning and optimization to other courses. So before they get to machine learning. So yeah, you can go that path, but that is definitely the programmer path. Programmers are needed, but it's not the same. And if you cut them off in algebra and don't at least get them to pre-cal in high school, they're going to lose a year or go on a 6-semester plan after the first year in a 4-year college.
And there are some large R1s have gotten rid of that AP Calc requirement. So we can argue about that too. Since we've gone down the math path, you've taken us there. We're going to jump ahead a question, but I am going to come back. So in the interest of giving time in the high school curriculum, particularly senior secondary, for richer exploration of statistics, what aspects of math curriculum do the speakers see as least useful to students and hence could be reduced or removed? And I forgot to mention, many of these questions were provided by our audience when they registered. So this was one of them. Do I need to read it again?
Yes, please.
Okay, so in the interest of giving time in the high school curriculum, for example, to explore statistics, what aspects of the math curriculum in K through 12 do you see as least useful to students, and then we could therefore reduce or remove it? So if we're gonna ask the students to study statistics, what can be taken out? Nobody wants to say anything about removing, but if you
It's like a third rail. I'll just stick my head out there because I'm not on any committees for math curriculum in any state. I would say like proof-based instruction, and like there's parts of geometry that are proof-based. Some people say, like, some people love proofs and that's how they engage with math. If it was up to me, I would be like, if everybody in high school could see a spreadsheet and know how to use a spreadsheet and be like able to master the concepts of a spreadsheet, we would be serving them far greater. The AP calculus question is like, what percent of high school students take AP calculus or take calculus? Maybe 20% take calculus and 10 or 15% take the AP. I don't know. Those are hard numbers to exactly figure out, but they're small. I think there's a thesis of data science education that's like, wow, well, the other 80% of the people that aren't taking calculus would be served by a data science class as like a pretty high probability, something they could use in their job in life. I'm pretty behind that thesis. So alternatives to a calculus pathway, I completely support. But on the other hand, if you want to come do data science at UC Berkeley, for example, having calculus is the way to get there. You can take calculus at UC Berkeley if you didn't do the AP calculus, but you're already a year behind if you do that.
Gemma, Carl, or Justin, do you want to comment on the math requirements?
Sure. So one of the things that I want to bring up, we're talking a lot about preparing people to be data scientists. So I think I'm really interested when I think about the curriculum in my state, and when I just think about mathematics, like if we're talking about the mathematics curriculum, which is super packed, right? I'm thinking about preparing everybody. So I'm thinking about students that maybe aren't going to go on to be data scientists, but they still need certain data science skills. So I'm certainly one that's going to, even though I know it's controversial, I'm going to advocate that we do need to make space for a pathway where we have data science courses, we don't want to create a low track, right? Like we don't want to say we have this non-calculus track, right? And the students that are not going to go into STEM careers, they start taking this like lower track because, you know, it's not as valued as much. That's not what I'm trying to say. But I do think that they're, like Eric said it nicely, students can take that calculus class when they get to a university, and there's no denying if students want to go, not even into data science careers, but a lot of math, computer science, engineering, you have to take the calculus. But I would argue that we would be better served to just prepare people in general to deal with all the data that we see everywhere to be able to make decisions. So I'm not just suggesting that even we think about not having students take calculus for some, but there are elements of like algebra 2, or we don't have algebra 2 anymore, but those advanced, everyone needs basic algebra, but these advanced basics where we're doing things with polynomials and other things, or things that can be very automated. We have a lot of technology nowadays that prepares us, right? Or that can do those calculations. I'm more interested in students being able to solve problems and to use mathematics as a tool to solve a problem. And when we can use technology to do that, it frees up some space. So I definitely am one of those that would say some of these advanced, you know, topics in algebra or even trigonometry, we could make some space out there for that.
Justin, do you have any thoughts on this?
Yeah, so I just came back from Cleveland, Ohio at the AP Pre-Calculus Symposium, and we had this argument with a bunch of mathematicians all weekend about what should be included in a new AP Pre-Calculus course. And just really thinking about how students understand what math is and are able to, as Jim has put it, use math as a tool. And I think now we have so much breadth within the math curricula that students come with a sample of mathematics and not a true understanding of how to use mathematics. So I would really push for students having a true understanding of using, working with polynomial functions, understanding some of the trigonometry, and not just the unit circle and memorizing, sine or cosine equations, but how do these things work so that you're actually able to use them to solve problems. And I know that AP has been looking at a number of different pathways in terms of math courses. We had discussions from AP Stats, AP College Algebra, AP Linear Algebra, because coding is becoming such much more important as a skill set, and an AP Data Science course, which I think there's still a lot of argument about what data science is. I don't know if it's clearly been defined as of yet, but as I would say, just really leaning into those skill sets that are going to give students depth of knowledge to be able to solve problems, as opposed to a survey of different functions that they might encounter in a math course.
Great, thank you. Any very brief comments? I want to move us along. Okay, so I want to come back a little bit to the messiness of data science and how that fits into a K-12 curriculum. There are constraints on K-12 education with specific outcomes and grading. So while it's great to say we want to explore the space of data science, how does that look at the practical level in high school? And maybe related, someone asked, another option might be to just integrate data science as a skill throughout the curriculum in high school. So I'll leave it there. Do anyone want to take that question?
Well, I think that to actually do data science justice, we may need to think creatively about how we're assessing students. That the old multiple choice exam is probably not the best format for assessing learning in data science. That there's some other tools and models that are out there. So if we think about technical interviews that are used at many of our large corporations for individuals to be able to show their knowledge, there might be some. We're working within some of our colleges on research into how we might be able to scale up that model for students to be able to engage in some virtual technical interviews where they're able to actually go through solving problems and it be more free form than choosing A through D on a multiple choice test, which doesn't really tell us much about your mathematical reasoning. And so I really think on the assessment side, there need to be some other models for assessing students if we're going to get them into the messiness of mathematics and really be able to exhibit their thinking, particularly when we're dealing with algorithms where there may not be, we know there's not only one correct way to solve the problem. It doesn't make much sense, and it introduces much bias into the system if we have one correct answer or we're thinking of one way of solving that problem.
Thank you so much for bringing that up, Justin. As a mom of a son who does not test well, standardized testing, it's certainly something we should all revisit. Other
Can I
panelists.
just piggyback on that real quick? This will be super brief, but I just want to give a shout out to Wake STEM Early College High School. So I love Justin's point about us thinking about these alternative assessments. They have project-based learning, and they use that across all of their areas at this high school. And the whole school has adopted that. They are embracing data. They're using data in their projects across all disciplines. So I just wanted to give that as another example of ways that we could start thinking about, assessing students in a way that relates to working with data.
That's fantastic. I hope somebody's capturing that in the chat or an archive of that, the link to that school that you just mentioned. Carl, I saw you unmute. Did you have something you want to add?
Yeah, I did. So the idea of problem-based learning and active learning, we actually build our program around that. And I'm another one of those students who did not do well on timed tests because I stressed out. And so I remember that it's not very hard to recall how you felt during that. So in the courses I have, for instance, I don't have finals. I have final projects. I have papers. I have other things, and I have other ways of testing their knowledge that I think are more sophisticated by doing that than by whether or not someone can guess or put in a correct answer to something. Now, I'm not going to argue that people are going to use tests, and we do for some skills things in preparation for our ABET stuff. We have to do some tests, but they're given like 2 or 3 times the amount of time they should need to do it. And they have 48 hours to do it, any 1 hour or 2 hours of their time, or their choosing within 48 hours. So I've tried to reduce the stress level on that, but I think that's an important thing. And then, on the thing about going data science across all the curriculum, I think it's a really good idea to integrate some of those elements. We've kind of done it backwards in our graduate degree, our undergraduate degree, you might say, in that we're a collaboration of the College of Arts and Science, College of Engineering, College of Business. So we have faculty members who teach the topics using what they work on as part of the topics. So for our introduction to programming, for the Python part, we have a bioinformatics professor who teaches it. And by the time they're done with the first half of the course, the second half is R. But by the time they're done, the students are kind of tired of the watermelon genome, but nevertheless, they've learned the programming and some of the case study stuff and that real world things based on the work that faculty member is doing. So each one of these faculty members brings that. So if you were to say in a high school, most of those folks, most of these teachers there have something that they were happy with or proud of their background, that they took up as part of their education. My wife was an LED teacher, so I had some insights into this. And so they could bring data science techniques into solving problems or case studies in the topics that they're teaching, for example.
Yeah, thank you for that. We're getting a lot of math questions.
Can I jump in on this like assessment and outcomes topic?
Yeah.
So I'll just say, I don't teach in high school, but I make a lot of notebooks for high school. I'm just, want to say to people who might be new to this, like I'm deep into the notebook-based instruction. So in my class, there's 15 notebooks that are like these long computational documents that teach you something and you code something and there's a challenge in there. And, I feel good about the assessment that's based on like, did you complete those 15 notebooks, and in the Data 8 class that I do a lot of work around like outreach and, there's a midterm and a final in that class, but the bulk of the class and a lot of the learning goes on in like 15 or 20 notebooks that you do over the course of the semester. So I'm just sort of passionate about notebook-based instruction and feel like it's a good way to like innovate in the space and get away from the high stakes testing and more into the like project-based aspects of learning. And there's a whole art to it. There's a whole like, how do you create the, coding challenge, inference challenge over the course of the notebook that, can be very variable, but I think there's lots of ways that this could be built out really well in high school and probably middle school as well.
Yeah,
I want to add
absolutely.
one more point.
Go for it, Justin.
Yeah, I think, to Eric's point, particularly like with, coding and data science, there have to be some opportunities to fail miserably in order to really learn. And like when we rob students of that opportunity, particularly with high stakes testing, like where, failure is just not an option. And students are so stressed out that they're not able to think creatively through solving the problem, that, we're really maybe cutting off some students who could be a real asset in those fields. And so, like, as we're thinking through that, I think there are some real opportunities for us to, build courses and assessments that allow students to, scaffold their thinking and go through that process of failure and iteration to build really, great logical and mathematical thinkers.
Yeah, really great point. We're really limiting the kinds of people who end up in data science with the assessments we have now. So I very much appreciate that. Okay, we're going to move now towards higher education. We spent some time talking about the K through 12 curriculum. And this one gets us there. What type of certificate, endorsement, or other artifact of success would your university desire from high schools or high school students to demonstrate their data science learning? And I assume this is beyond just showing on your transcript that you took a data science class, but is there another form of endorsement, certificate, artifact? Carl?
Well, if you do a pathway, like through your state program, like ours has an official pathway, this would show up on their transcript. So it would show that they had done that. And because we've designed it, because we're doing this ecosystem where we've all agreed for the opt-in 2-year and 4-year colleges to this, so you could start anywhere, finish anywhere. So we feel these to be the equivalent of 2 particular courses in the first year program. So if you've done that, then you can actually bypass or get credit for equivalency for 2 of the first year programs in any of the colleges and universities who have opted in the state to this program. So for us, that would be sufficient, and it would show up in our course equivalency things, and it automatically get credited as they came in for advising for orientation at any of the schools.
Yeah, no, that's fantastic that you have these pathways available.
I put a link, by the way, to the pathway in the chat. Yeah.
Yes. But for those schools who don't yet have these K through 12 to higher ed pathways, or maybe Jima, Eric, Justin, do you have something similar?
Yes, we're currently working in Georgia to develop the data science standards for the state. And one of the turf wars that's happening right now is between academics and what we have in Georgia, CTAE, the Career Technology and Agricultural Education. And, really thinking about for students who may not have initial plans to go into a 4-year institution, what are some low barrier to entry careers that they might be able to pursue? And so to that end, like we've been looking at how these things align with what industry standards are. And one of the items that is likely to be included is some opportunities for students to gain certifications through companies such as Cisco, Google, or Microsoft, and have those certifications coming out of high school, which if you're coming into college and you're certified in Cisco, Microsoft, or Google, that pretty much proves that you have some level of coding that would be useful in a college classroom, but it also doubles as a way for students who may not be going into a 4-year institution right out of high school to have job opportunities.
Justin, can you just clarify how that works? Do they take the curriculum as just a part of their, instead of a different class in the high school?
So it would be embedded into the class. So you might have certain certificates, whether that might be the one that we're really looking at is with Cisco and cybersecurity. So like certain badges that they're able to earn that are part of the curriculum for Cisco that would be embedded into a class. And so in addition to saying that you took this class or this course while you were in high school, you also earn these badges or certificate that are certified by either Cisco or Microsoft that say that you've obtained this level of skill in a particular area.
So I'd like to add one thing, if I might. That we, even though we're the four-year school and we're looking for four-year students and 2+2 students, we took the decision that we were going to help all these kind of certificates and trade schools and apprenticeships and everything, because we decided at the beginning that Arkansas is small enough that we could do this, where a lot of larger schools we usually say in the coasts wouldn't. And we're small enough that we can't afford not to. So we decided that we would help everybody. And so we provide course lessons, syllabi, recordings. In the summer, we do a Teach the Teachers, where we'll teach them how to teach the courses and give them all of our assignment and course, test materials and everything.
That's great. Thank you. So let's see. What are some of this is now focusing more on the higher education space and gets a little bit at a question that was asked in the chat on the distinction between data analyst and data scientist. But I think it gets at also what's the depth of data science in higher ed. And so when we think about, for example, a data science bachelor's degree, what do you all see are some important topics that should be absolutely required classes for this kind of a degree, and what should be just an elective? And I guess it gets at they get back to the tool user versus tool builder too, right? Eric, I see you nodding. I think you have something to say.
Sure, I'd say the data scientist is going to understand something about algorithms, something about coding, something about how to build things. In our intro data science class, you write some of the key algorithms like as part of the first class. And then, as you go up, you still keep coding some of those big algorithms from scratch. And that's really different than like just applying and calling something from out of the box software. I think data analyst could be something that's like a 2-year college could even be able to like teach to. There's definitely a lot in the like business analyst space as well that's sort of overlapping. It's interesting for me when I go out to meet with community colleges. There's people from the stats department, there's people from the CS department, and then there's also people from business analytics. And those are sort of all people in the space. And there's definitely like, courses in business analytics that have lots of elements of data science to them, but a lot more application and, projects of applying something to a data set. I think you have like a few different questions sort of wrapped together here. I think there's one on what should be required and what should be elective. That's really interesting. I mean, for us, so we have 2 core classes, the lower division 1 and an upper division 1. And even the question there is like, what are the things you get in that, in that semester? What are the key, you can only fit something into 15 weeks of like a core class. And I'll just also bring up the flag of like ethics and, where's the role of that in data science? Like UC Berkeley's said, like, all right, you're going to have a whole separate class on ethics, and that's going to be required for your major. But also at the same time, like the team works with the people in the core classes, the lower div and the upper div class, to make sure that there's some ethical examples in the project-based work in each of those classes as well. And then I would have to say, like, folks are mentioning linear algebra all over the place in the chat. And, I think there's a definite room for innovation in the linear algebra space. Like, what is math for data science? I think that there's some people building new things in this space, but it hasn't necessarily like congealed or there's not a consensus about what this would be. I'd really think it would be amazing if there was like a high school branch of this work as it grows as well. It's also just been educational about working in higher ed, where like the people that teach the math classes are over in the math department and their agenda is not necessarily data science. And people who generate math curriculum might be math educators, and they might not be like all the way aligned with data science. So how much does data science bring its own people and create its own curriculum fresh? And how much does data science like reach out to the people who are already in the space, who are already defining curriculum, who already have like conferences and workshops based on math education, and like go work with those people, those existing stakeholders?
So I wanted to add to what Eric was saying. I definitely agree. People definitely need they need experience and training in terms of coding and classes where you can use scripting and coding to work with data. But I also wanted to kind of distinguish between mathematics and statistics a little bit. I'm not going to say a lot, but to me, someone who is a math educator more generally and with a math degree and a statistics educator, there's a lot of differences between mathematical thinking and statistical thinking. So I would kind of argue that while math is often a tool, that having a deep understanding of statistical concepts is definitely going to be necessary and carry you forward in terms of data science and what's necessary. And I think going back to, I think Carl and Justin and I touched on this earlier, it's also this being able to work in teams and using the right expertise and the communication. I know that in my graduate classes, teaching statistics students that are already working professionals with big data, that's one of the things that I know I've worked with them a lot and I've gotten a lot back from, is thinking about how can I, as a data professional, help other people, my client, right, or other people, other stakeholders, understand data in a way related to some problem, and having them be able to understand the different levels of understanding people have and the right tools, right, and representations and models you can share back with people when you're trying to share that this is a proposal I'm giving you that's going to provide a solution or action. I do think those courses, or experiences where they are building experiences as teams, working together as teams, communicating solutions to problems, through their models. All of those things I think are really necessary as well.
Speaking from the standpoint of, I've been working for I've been working for the past 2 years, but it's been a 3-year undertaking to build a data science minor across 4 separate institutions. And we're still having these arguments about what should be included and what should be elective at our institutions. But I think we've settled on a few elements that are going to work across all institutions. We start with the data in the African diaspora course, which would be like an ethics course where we look at data and its usage in society, and how data is not innately objective as it might be projected in many spaces, that there can be many subjectivities that are placed into how we analyze data, and to be aware of that. We also have students must engage in at least 1 to 2 coding courses, and those can be across the board. Typically they're Python or R. We have an AI and machine learning course, and then all students are required to have both stats and some level of pre-calculus. Sometimes we substitute college algebra for the pre-calculus or calculus requirement, depending on the major. And then a research or internship, because we're working broad field. So we have computer scientists mainly, but also social scientists, business analysts, and I also teach a data science and education course, being a STEM educator. But the electives kind of work inside of the discipline, and then we have like this base of 4 to 5 courses that are required for everyone to obtain the data science minor.
Great, thank you for that overview. Does anyone want to add to that before I move on? Okay, it sounds like my next question was about the state of the data science curriculum, but I also want to be cognizant of time. And I think I want to instead now turn, because it sounds like most of you have described the state of the data science curriculum, to something that might be helpful for the students in the audience. More and more schools are offering purely data science bachelor's degrees. So how should a student choose then between a data science bachelor's versus a degree, for example, in another field, and then adding a data science minor or a certificate, especially to ensure they're best positioned for being on the job market? Anyone have thoughts on that? Carl?
Well, it turns out this question comes up a lot during orientation, and also it came up a lot with employers. And so, since I had done this before, I actually created a table that has computer engineering, computer science, information systems, business and data analytics, statistics and data science in it, and then talks about, what they do, what the degree coursework is like, what their responsibilities are, what the tools are they use, what the career path is, and the industries that hire them. And I found that to be really useful with faculty too, I should add, but with parents and students and around, we distributed around, and the objective that the best thing to happen is to have someone find the thing that's right for them. And so and part of this brings out the distinction between someone who is studying analytics of some kind in a major versus a data science student who has a concentration in a domain. So the data science student is first a data scientist, and then they've learned a domain. And I tell them that based on my own experience, you're unlikely to end up in the domain that you started in. In fact, you'll probably go through several domains, but the key thing is to learn one. In the other case, so like, let's say that you were taking an analytics course in an industrial engineering department and studying operations analytics, you're an industrial engineer first, and you're applying analytics to work on manufacturing and operation stuff. Same thing with supply chain. So in one case, you're a data scientist applying data science techniques to solve problems there. And the other one, you're the other thing using analytics to help you get insights to it. So they aren't the same. And the focus of them is entirely different, even though there is some crossover. So I think that's, and by the way, I'm glad I tried to upload the PDF for that, but it wouldn't let me upload it into the chat. So if you all want me to send it to you, I'll send it to you and you can distribute it out.
Yes, please do. That's cool. Jima or Eric, Justin?
I'd say the answer to that question isn't so clear anymore, because people don't tend to stay in career fields for, graduate college and you stay there for 30 years until you retire is not the typical game plan for most people. So I would say even more important than the major might be the experiences during your undergrad stay, making sure that you're interning in at least 2 different domains before you graduate from your chosen degree program. So in that way, you're able to interact in some of these spaces that you gain the experience. And then when you're looking at your resume, if you have an interest in computer science, if you've done data science and computer science, it's on your resume, you work with the company. If you've done something in biotech, that's on your resume for things that you've done. Because more and more companies are, looking at the students that were graduating. You took these courses, but what does this mean? And they're trying to work out this as a function of how long are we going to train you before you're useful. And having that internship experience with a company, and in many cases I've seen with students, is much more effective if they're looking to work in a particular domain.
Yeah, 100%. Eric, I don't know if you were at Berkeley when we were used to talk about pie-shaped people. I think that a lot of people were talking about this, how you're pie shape where you're very strong in a domain and data science, until we all realized that was a unicorn and not necessarily realistic, right? So data science succeeds when we're in teams. Getting back to your point, Carl, about teamwork and how important that is. Where to focus feels very personal, but I don't know if there's any other suggestions that you all have. Okay, I think we'll move on then. There's another question here. We're going to now loop it back to K through 12 in some ways. And I'd like to ask, again, comes from one of our participants. what vertical alignments are there from K through 12 through community colleges to four-year programs? So are you aware of any of these and have suggestions? Yes, Carl.
Yep. Well, we have a set of things that started through a thing that we call STEM, or I'm sorry, STEM Prep, where we've got agreements with most of the two-year colleges in the state to for us to actually teach some courses online that their students can register and pay their rate, and then we hand register them as a non-degree seeking student, and it's an online course with some real time with a faculty member. So I've just put the first one of our data science courses out into that. It includes Cal 1, 2, and 3, university physics, and engineering fundamentals or something, plus the introduction to data science that I've done. And then I'm putting the role of data science in today's world second course out there for this coming spring. So what we've done with the two-year schools is we've taken the model that we've got, and this goes back to creating agreements with them that if they opt in, then we agree to do certain things in helping them and their students prepare the courses. And what that does for us is it, without a doubt, it improves the number of students who at least get a two-year degree or some kind of certificate at two-year colleges, but it gives us a better feed of students that are more diverse than we might otherwise attract. Because if we combine the two-year schools and the HBCUs that are not traditionally the two-year schools that we deal with, we get a better mix of students. And by helping the other four-year schools in their regions, with this program as an ecosystem, we already know that the students going to two-year colleges, particularly HBCUs, prefer to go to a four-year college near them. So they're not all forced to come to where we are, but we have what we've called them as hub universities in each part of the state. There's one we're in Northwest, and there's one in Northeast, one Central, and one South, so that they actually have somewhere that they can go to that's relatively close to their two-year college if they choose to. But it's up to them. But we've been working on this we're in our third year on this program. NSF and EPSCoR both said that they're interested in what we're doing, and I think Mississippi has begun to model what we're doing already. But the idea is that we could potentially replicate this in the EPSCoR states. It's a way of helping others help themselves, teach the teachers as opposed to doing the fishing for them. And so as a land grant university for the state, we feel we have a responsibility to do this. And the old saying, when the tide rises, all boats rise. And you'll get an argument that says you're training your competition here to the University of Arkansas. And there's no way, even if they did, that we could train them all. It's not possible. So the best thing to do is, they all know we're the land grant college. You don't have to really, do that. And they really expect us to help them. So why not? We lose nothing. And we potentially gain great students along the way.
That's a great perspective, Carl. We're almost out of time. Eric, did you want to mention anything about the California Alliance?
Yeah, I work actively in the space as well, not from the high school perspective, but trying to work with community college and UC. It's a weird many-to-many system. So there's like 100 and some, 120 community colleges and, several UCs with data science programs. Technically the system is like a one-to-one articulation for a class, which seems very unsustainable. So what can we do to lower those barriers and make it more possible for a many-to-many articulation? And some of what I do is just gathering people and who's working on what and try to raise the voices of other folks. Last summer we turned around, we're like, wait, of the 1,000 people in the data science major at UC Berkeley, 200 of them almost are community college transfer students. So I'm working really hard to figure out this transfer thing. And there's hundreds of kids that are just sort of flowing into the system and figuring it out their own way and doing what they can to find this cool new major by themselves. So that's sort of amazing. And what can we learn from those students? What can we learn from their pathways? Can we follow their way up and how they got through? So I'm excited to keep innovating in this space. And I think, as Carl said, a whole bunch of things, it's going to empower everybody. It's going to build more capacity. It's a pathway towards, increasing diversity in STEM. It's a pathway towards, innovating in math education and CS education, that more people are at the table.
Awesome. And I know I'm getting that like angry, we need to wrap, but I'm going to give Justin or Jima 30 seconds.
I'll be
to
really
add.
quick and I'll split it with you, Justin. So I just also wanted to advocate for thinking and leveraging other structures other than courses to support the development of data science skills and proficiencies. So for example, we started building MOOC Eds a long time ago at NC State. And now with our partners at RTI, we're building professional learning spaces for individuals to come and learn for free. And I just wanted to give a shout out to my colleagues in the Data Science Academy at NC State. This is another way to think about courses that are available to all people that can come and learn data science skills and the ways of thinking. And just we need to leverage all of these different things to support people in addition to traditional coursework.
Yeah, Justin.
And I would just say for the framework, we haven't figured it out in Georgia yet, but I know Virginia is one of the states that has implemented data science for K-12. And Dr. Seshire, I think he's at George Mason, like we've been working with him, looking at some of the things that they did in Virginia, actually working alongside K-12 teachers to figure out where these things fit into the curriculum in order to make it streamlined. And then lastly, I'd just echo Gemma. One of the things that we're really looking to do in Georgia is also build these skills in informal learning spaces early on for students. So we're working with a grant that we received from NASA on a machine learning program with elementary and middle school students to teach them coding and machine learning from an earlier age. So like when they get into high school and they're exposed to data science, they've had some of these informal learning experiences that help them to have schema and models for engaging in data science.
That's fantastic. Get them young. Right on. Okay, thank you, panelists. I'm going to turn it now back over to Zarek, who will wrap us up.
Yes, and thank you all so much. Thank you, Michaela, for moderating. I want to thank all of our fantastic speakers for joining us today. I hope this gave you all an insight on the design of college data science programs from the designers themselves. All right, tackling this field is challenging no matter what level you're at, whether you're in K-12 or higher ed, but I think the proof is in the pudding of just how many institutions and how many people are trying to tackle these disciplines, and all the more important for building data-related skill sets for our students. And finally, this is a great display of higher ed partners who can serve as resources for K-12 practitioners. So please feel to reach out to any of us if you're thinking about bringing these programs to K-12 arena. I'm going to run through a few housekeeping things as we sign off here at the end of the event. So first, just a reminder, we hope you will continue to keep the conversation going with Data Science for Everyone community. We have several ways to get in touch, including Slack, our newsletter, a reminder to follow us on LinkedIn because we are hiring, and then finally Twitter. We also wanted to, I know I saw some messages in the chat about resources to bring lesson plans or activities to your classroom. We have a great resource center online where we aggregated a lot of these things. And if you don't see something on there, please let us know. Finally, I wanted to quickly plug that we are running a survey of our coalition. So I want to give a friendly reminder to please complete the coalition survey. We want to hear from you all about what you think about data science in K-12. And a few lucky people will be randomly selected for gift cards. So very exciting as our attempt to increase survey responses and drum up some excitement there. And then finally, we're always happy to connect. So please don't hesitate to reach out. Have a great rest of your day. And we hope we'll see you at a future event with DS4E.